Okay, so guys, um, let me probably I should start this way so that I won't waste time. I really want it to be a productive session. Probably we should like discuss like okay, area exactly regarding pointers or area exactly regarding arrays or strings that we actually need clarity on, or probably I should just talk on pointers and then work with um the project, or probably you want me to work with a particular project and then try to see what I mean, like how we can solve it and then explain some of the things, how we come about the answers. I don't know if we get what we are saying. I don't want to just start something and it could be something that we've already known before. We don't want to waste time. We want to actually make this thing to be productive. So that's like a suggestion from my end, and I want response actually. So I'm talking to
Okay. In that case, how about we say like go through the projects probably from the first one, then we explain. I would say I did not really understand the fact that there is a source, there's a destination, and there are pointers to them, and then all of these and all of that. The ones that I was able to actually understand and do by myself were the ones I had to do with the ones that I think converted text to was it converted text from lowercase to capital letters. Those ones were a bit they were quite easy for me.
okay, okay,
Aside those ones, I don't think they were.
okay. Let me. What about you, Caroline? Let me hear a point of view and see how I can merge everything together and we can start something.
I think he's right. We can start there. I don't have a problem.
Okay. So I'm gonna start with this one, this very one, a function that concatenates two string. Okay. I think before I come to this one that concatenates two string, there is a kind of a series of them that starts from, I think from this side. Let me try to see. Which of them? Okay. Not this. Okay. Let me just start from here. So okay, so a function that concatenates two string and they're giving us the prototype, okay, and then they've given us some description where like how does the string cards work, okay. What is here actually is that the C in the C library, yes, the C built-in library, there's a similar function which is this guy that I highlighted, strcat. So it actually concatenates strings. And what does it mean? That is like concatenation means to join. Okay. So you have a particular string and you have another string, and then you join them together. So on you will actually understand uh how to create a string in C. So without like just going back, we already understand that a string is just like what is a kind of array on its own. So a string is what is a sequence of characters, all right, enclosed in the what double quote. So for example, if I create a string, if I do car and I create a string, a pointer to a string, okay, or let me just create a normal string without even writing pointer to anything. So I'm just going to a string and I call it name or names. Then what I will assign, I will use this square brackets, then what the name of the string. I mean the not the name of the string, the content of the string. Okay. So let me say let me just call it let me call it just name. So John. Okay. Oh no, let me look for something longer. So let me say sentence. If I actually I can print this string using printf, okay, So I can print this string to the screen using printf, and I use format specifier %s, and then what, I reference the string. Okay, so if I do this, I will have the output like this. John is a very big boy. So what we need to actually look at is that you see every of these bit of what, every bit of these characters, that starting from this John up to what, the boy, or I mean to this new line, they are all characters that in fact I can loop through what, this sentence. I can loop through it. Like I can output the individual character. So if I do a for loop and I say for int I equals 0, and I say let I be less than, now I can actually do add coding, like trying to count the elements of this string, that is individual elements, individual characters. So 1 2 3 4 5 space 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23. So like this is all the elements, they are what, they are 23. All the elements in this was string. But instead of doing this, there is a handy what, there is a handy library in the C, um, built-in library that I can use, which is what, if I input string.h, if I include string.h in this my code, I will have access to that library. So that library will give me what, it will give me the access to get the length of a string. Okay, so when you are printing an element in an array, you actually need to know the length of that array. When you say the length of that array, you are trying to talk about the total elements in that array, so that you can use your loop to continue while your counter is what, is less than that what, size of the array. So if I use that function is called string length. So string length, and I what, I reference sentence. So like this, it's what, it has already automatically get the length of this string. I can use this guy as a case in order to what, to loop through this guy. That is one that is one way. Okay, so if we quickly try to print out the output of what string length will give us. So if I do print f, let me just do it on one line. So if I do print f and I say %b, okay, and I reference the string length, okay, that I have done here, so it will print out the length of that string for me. Okay, something is wrong somewhere. Print f.
Line 8, second quote.
Okay, thank you. No, that okay. So if I run this, so you can see the length is 23. So if I do something like from this point and I say for loop, and I say for int I equals what, 0, that is the starting point, because we know that arrays are indexed in 0, from 0. So you cannot, like, this first element is what is in index 0. Okay, so if I now say for int I equals 0, and I say while I is what, less than what, um is less than, so let's do something, let's just save this length into a variable so that we can have access to easily use it. So I'm going to say int, because this output that we got here is an integer, so I'm going to say int what, length equals, int length equals, then that is, it will retrieve the length of the string. Okay, sentence for me, and it is 23, so it will store 23 into length. Okay, so I'll now see why I is less than length. Okay, as long as I is less than length, if I becomes 1, 2, 3, 4, 5, 6, like that, until what I becomes 23. That is when the loop will exit. So I will now say what, continue, that increment I. So, and we know how the for loop works. So I can now say I want to output individual characters. So I'm using format specifier character now. I want to output the individual characters, okay, of this string sentence. So I'm going to say I'm outputting every character. So that is from every position of I. That is, I'll be having something like sentence zero. Then at sentence zero, what is the value here? J, to print J for me. Sentence I, it will what, print sentence one, it will print O for me. Like that. That is how the loop, okay? That is how the loop will work. So I'm just going somewhere. So if we output this, sorry, yi is less than length, yes. Printf individual characters.
Think a new line or something.
Not a new line. It's actually even printing the whole of. I think something is missing. Okay. I think I didn't run it. Okay, let's do this. This, it is coming from this place. This one here. Okay. So you could see each of what, each of them, J up to the last guy here, boy. So at least you could see how we are able to output every element from this what, from this array, from this string array. Okay. Now this is one way I can use by what, trying to make sure that this guy continues to print until get to the last guy. But there's something that we need to understand, that for every string that you create, there is something we call a null terminator. When we say a null terminator, it is this symbol that you see here, this symbol like this. This is called a null terminator. And what does this do? This is used by the what, the compiler, to detect the end of a string. So that means if I don't want to use yi is what, less than length, okay, I can say that I can do something like this. I can use this alternative. Okay, let me disable this one. So I can do something like, I'm setting I to be 0. Okay, that is the index start from 0. And I can say why is every position at I, sorry, sentence, why every position of the sentence string, okay, don't get it twisted, why every position of this sentence string, or as long as every position of what, this sentence string. And what are the position? Position 0, position 1, position 2, position 3, 4, 5, 6, like that, up to 23. As long as every of this position is not equal to the null terminator. That is the explanation of this statement here. So I'm setting I to be 0, and I'm saying that as long as what, every position of this sentence, okay, the sentence string is not equal to the null terminator, then therefore print them out, print every of this position out. So that means this thing will only terminate, this stuff will only terminate, or this loop will end only when it gets to this guy. When it sees this guy, then it will stop. So obviously we are going to get the same value or the same output like this. So if I run this guy, so we could see we have the same output like this. Okay, so now the point now that we want to do is what, we want to create a string that will concatenate, okay, a function that will concatenate to string. So I'm going to open another compiler here, and then we are going to use the prototype given to us. And now I believe we already know how to use prototype. This one is going to be header file. and then it will be in the header file. So it is from the header file we include it into what? The main function. So if you look at the example they did here, sometimes people get twisted or get confused, like what is happening by looking at what? Looking at this sample here. This sample is actually what? The main function that is used to test your function. So the main function is the entry point for every other function or every other code that you write. So if you can look at the top here, you could see that they included what? The main.h header file here, because it is where the compiler or the main function itself will look into in order to what? To use, where is the function? To use this function that they put here. Okay, so the main function will look into this guy here, and then if it sees this function here, then it will use it according to what is written in that function. So what are we going to do now? We don't have header file here. Instead, we are going to write. Can you mute yourself? Sorry, I think that's Caroline. I see a message here. Okay. Okay, thank you, Caroline. So the function they ask us to use is what? The string, uh the prototype, the string card. So I'm going to copy it, and then what am I going to do? I'm going to put it here since we don't have a header file. So we are going to what? Put it this way and use it. But before that, let us try to see how does the string card work. Okay, and then before we even code anything first, we are going to try to look at the algorithm to see how this thing is going to work. Because if we just start coding without even understanding what we want to code, that is how this thing gets complicated. At first we need to see how will this thing look like, try the output. So I'm going to do man string cards, okay, by the side, and I'm going to open Google Doc so I can use it to do some writing. Even I have a style plus, but it could have been easy, but all the best. So I'm going to create a new. I'm going to create a new this thing. I'm going to create a new document here. Okay. So this guy is open, and let's see how it works. So if we look at it here, we could see that the function is actually a pointer. Okay, and it is a pointer to parameters that receive a string. Okay, so the parameters in this function. Okay, let's break this function down. Okay, so this function is a pointer to a string, one, and it receives parameters. When you are using a function, when you are creating a function, sorry, when you are creating a function, at that point of creation, when the function is to receive some inputs like this that we are seeing here, we call them parameters. So all these guys here, they are called parameters. That is, this function is going to receive two parameters, which is what? Card destination, and then the card is source of which we want to what? Concatenate. So that now when you want to use the function, like when you are calling the function, when you are calling the function to use it and you are passing values to that function, or you are referencing values to that function, that is when we call those values you are passing it into it as arguments. So when you are creating the function, the values that is necessary to be put, okay, like this, are called parameters. And when you are using it and you are passing values, they are called arguments. Okay, so now what is this function going to do? It's going to receive two parameters, which is first one, the first parameter will always be the destination, and the second parameter will be the source. Okay, so first thing is like we need to understand what does it mean to concatenate something. So to concatenate is mean that okay, we want to join like two string, as in this case. So now that means this the second string will be the source that we want to what join into the destination. So let me use this as a writing. So if we have something like this, if we have something like this, and then we sorry, where is it called? Okay, so we have something like this, and let's assume that string 1 is equal to my friend or my good friend, my good friend. Okay, and then we have string 2, which is the source. Okay, so string 1, string 2, and string 2 is what my good friend is here. Okay, let's assume this one have space before it. So what they are trying to say is that we are going to have the string 1, and then we are going to have what the string 2 added to it like this. So it will be like string 1 plus string 2, in the sense that of course the final output will be my good friend. Then we have this space, and then we have is here. Now, how do we achieve this? How do we get this? How do we um, get to this solution? Firstly, the thing we need to understand is that we have two strings, and this guy will remain unchanged. I mean, this guy in the first instance, this one is the one that is what's going to be added to this guy. Okay, and I'm just trying to think. I could have like thrown the question out, but one thing that we need to see is like at every position. Okay, one of the things we need to understand is that at every position of, let's talk about the string 2 now. At every position of the string 2, from the space to the I to the S to the second space like that to the end. Okay, all of these parts, they are positions. So what we can do is that this string 2 cannot actually just copy itself like from here and then copy itself totally to this guy here and form this string. No, the point is that every of the position from string 2 will be added one by one to string 1. Okay, so in that case what I'm driving at is that we are going to be needing like a loop. So we will be needing like a loop. We would need to loop loop over the string 2 characters, okay, one after the other. That is one thing I'm thinking at. And two, another point is that we are going to loop over this guy, the string 2, as long as what every position is not equal to the null terminator or terminating um this guy here, because all of them they have this. We understand that every string they have the terminating uh, character. Okay, so I'm going to say, okay, this I want to loop over this string 2 continuously as long as what every of the characters, every of the position is not equals to this guy. That is, when it gets to this guy, it should terminate. Now, two, the point is that I'm going to say that I want to actually set string one because um string one now at this point is that string one is totally like this, but we need to understand that we are joining. Okay, so this is where we are going. We need to understand that we are joining this string two to string one. I've said this before, but this string one remains unchanged in the sense that we are adding this set of characters to the originally existing character of string one. So what am I trying to say is that we are going to be adding this guy to the end of this guy. So what we need to do is that we need the length of string one already, okay, such that, okay, let me put it that such that if string one, if length of string one is equal to 7, okay, then the addition of string 2, excuse me, the addition of string 2 starts to join, or the joining of string 2 starts to join from position 7 of string 1. So it will be like this guy is already 7, and at the position of um at the position of string 1, that is when we start to what? Add string 2. Now let's look at something. Let's look at the description of the synopsis of the string cat, how it works. So there's something that said the string cat function appends the source string into the destination, overwriting the terminating null byte at the end of the destination. Okay, and then adds the null terminating byte. Okay, the string may not overlap. All this one is by the side. So let me explain what they said by that side is that, let's say, if we look at this string now, look at string one, and we have, let's count from here, like the value. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is very obvious here that the length of this string is actually what? 16. But if you count the individual elements indexing from 0, it is what? The last character is 15. Okay, so that means if we are going to start the appending will start from length of string 1. Okay, so it will be length of string 1 minus 1. So if, for example, I use a loop like say string 1, then my position will be the length of string 1 minus 1, and then that is when I'll now say I'm appending. So if I say from this position, I'm assigning every point of string 2. Let me stop here and ask a question. I don't know if we are confused or we get the logic that is happening there. Guys, any question? Who is following? Who is confused, please? Ah, sorry. Is it that network is bad or people are not there?
Hey, I can hear you. Oh, I want you to say get out of this. It seems you are still somewhere. Then we can ask question after.
Okay, that's from your own end. Okay. Another person, I should continue. I think that is like a general, a collective answer, response rather. So let me recap. Look at, okay, let me use an analogy. Let's say you have um you have 5 biro with you in your left hand, 5 biro. Okay, You have 5 biro in your left hand, and the place I am there is not okay. I could have used my camera for you to see my hand and see my analogy. But you have 5 biro in your left hand, and you have another 4 biro on your right hand. And now, what do we want to do? We want to join the two together. Okay, we want to join from my left hand, I mean from my right hand, the 4 biros on my right hand to the 5 biro on my left hand. So if I say something like this, let's say I have left hand, okay, 5 biros, and then right hand, okay, I say 4 biros. Now if I'm to join this guy, what I'm going to do is that I'm going to start my journey from 5, and then start to add individual elements or individual biros, sorry, on my right hand, one by one, one by one, to what? To my to the biro on my right hand. This is actually the way it will work in the computer, in the system, because you cannot just put on, just like humans, you can just like put the 4 to the 5 together and then what, start counting from the top. No, you cannot, because everything, the compiler, everything, they work line by line, one at a time, and that's why they call it a loop. It will what, perform each of um the repetition. It will do it one at a time, as if you are counting oranges from a bag into a bowl. You have to take it one by one, one by one. That is how it works. So what has have to happen is that what, I'm taking the length of the total biros, actually the total numbers of biro in my left hand. I have it with me, and I'm starting from that position to start adding each of the biros on my right hand one by one. I think this just explain the analogy and the algorithm of how we are going to like come about the solution to this problem. So what we are trying to say is that we need to actually get the length of string 1, okay, but the length of a string will actually count, it will start its counting from 1. That is, to count the counting, if we say string 1, it will start the counting from 1, 2, 3, 4, all to the last. Okay, that will give you the total length, that is how many elements is inside here. But if you are actually trying to target individual elements in a string, or in an array generally, sorry, in an array, you need to start counting from 0, of which the first element will be indexed as 0. So 0, 1, 2, 3, 4, like that. Okay, so in that case, if the length of my string is 7, if the length of string 1 is 7, therefore the last element will be what? Will be 7 minus 1. So that is like even a logic for me to get the last element. So last element equals what? Length, okay, minus 1. That will target the last element for me. And this is necessary in accordance to what? In accordance to this guy here. In accordance with the description of how the string cards work, because it's what? It appends the source string, the string 2 that we want to add to string 1. It appends it to what? To the destination. And how does it do? It does this by overwriting the what? The terminating null byte. It overwrites the terminating null byte. So of course we already said that the last value is what? The terminator. Let me put it that way. So we need to get the terminator, we need to what? We need to get the length, and then minus 1 from it. It will give us the terminator. So in this case now, if we run our loop now, if we run, well, how are we not going to do it? Let's say now we now have to loop over. So we need to loop over, sorry, we need to loop over the string 2, okay, that is individual characters, okay, and then assign, okay, Let me take this one to new line so that you can see. And then assign the individual characters of string 2, okay, to the to string 1. Okay, let me put it this way, to string 1, but starting from the last element. Okay, so if, let's say, if I is equal 0, and then we say I, okay, we say string 1, that is this at position of string 1, as long as the string 1 and every position of string 1, okay, this is what this thing means, as long as every position of string 1 is not equal to the null terminator. So I'm explaining this statement. So we can say we are setting I equals 0, and as long as what, every position of string 2, sorry, as long as every position of string 2 that we want to append to string 1 is not equal to the null terminator, then we are going to say, then set string 2 at starting from the last element position. So that's the meaning of what to be inside that place. What are we referencing? Assign it, okay. So we are trying to set into this guy. What are we setting? Every position of string 2 of I. Okay. Then what? We are going to say increment I so that the loop will continue. So this basically will do all the addition of every element of string 1 one by one into this position, and this guy of course will keep incrementing. So if initially length of string 2 is equal to 7, okay, after the appending, okay, the length of string 1. Oh, I've missed something here. Please don't get miss it up. Don't get confused. Sorry. If initially length of string 1, the destination string, okay, is 7, after appending, the length of string 1 will be equal to what? 7 plus the total number of string 2 that we appended. So now let's write this thing in a way that we will actually understand it. So we'll say our pseudocode now, okay, because that is just like a way to understand what we are going to write. So if we now say pseudocode, and then we now say first thing, let's start, okay, line 0, and then we say get length of string 1, okay, then 2, loop over string 2. Okay, so we'll define a loop. I, okay, counter, let's say I equals 0, okay, while I is not equal to what? While I is not equal to the null byte, okay. But now it's not I at this point because what we are trying to what, loop every position of string 2. So we say while every position of string 2, so that's what this means, is not equal to null bytes. So what are we going to do? We are going to say let string 1, okay. So we are going to say let string 1 at position of what, length -1, okay, that is targeting the last element, starting from the last element, let it be equal to what every position of string 2. Okay, so let it be equal to every position of string 2. So in this sense, in this case, it will make sense. So at that point, we'll say we'll increment I so that it will keep moving. That is, every position of string 2 will keep moving. Sorry, this place will be I. Okay, so that will be what for the loop. And when the loop ends, what are we going to do? Let's look at the manual. We said it is going to overwrite the null terminator at the end of the destination, just like we said. So after that, then it will what add the null byte. So that means we will now say string position of what string position string 1 at the position of string 1 at the position of the final counter, because when we run this thing, you get the idea that is happening here. Because at this point, I will become plus plus, I will continue like that. Okay, so what is going to happen is that we are going to set at the position of I, the final I, to be equal to the null byte according to what is here. If I go back to here, what why did we add this part here? Don't get confused. Why did we add this part here, this null byte? Is because of this guy here. He said we are going to add the null byte after it has finished overwriting the null byte from the destination. Okay, so after this, after all of this has finished, right, then we are going to what add the null byte, and then we have finished the concatenation. That is how this thing will continue to concatenate string. So this I don't know. Let me just let's input this pseudocode now, and let's make it make sense, because some persons might like be confused, but don't get it twisted. So I'm going to take this one out so that it can be I can see them. Okay, sorry. Okay, where are you? Okay, so so what do we do? First, let's say in length. Okay, so we need to get the length of string one. So let's say int length equals string length. Okay, string length of destination. So this will get what get the length of destination. So don't forget our parameters. That's what we are working with here. But don't forget this one will not work without imputing what the string library. So hash include string.h. Okay. On on a normal day, they have asked us to create this guy too. Okay, and we can still create this guy and like this function that returns the length of a string. The logic for this one is that we loop over the individual characters as long as they are less than the null byte, or they are not equal to the null byte. Okay, so we loop over them, and then we return the total amount of values. Let me don't divert. So this guy just gets the length for us. So that is number one of our pseudocode. Now number two is what we want to loop over the string 2, that is the source. So let's create a counter and say set I to be 0, and we'll say why I, no, not I this time, position at what source, okay, is not equal to the null bytes. Okay, then what do? We are going to say string destination at position of what length minus 1 to get the last value. Okay, and then we assign it to what the position of the source, right? And then we increment I plus plus. Okay, then After this loop has finished, we will set destination at position of I to be equal to what? To be equal to the null terminator. I'm kind of skeptical about this because if we count, I'm skeptical, yes, I'm skeptical, but we'll still check. If we count the total amount I will be, because I is zero from here, okay? Let's assume that the source, okay, the source string is actually, let's say it is this guy here, gets, okay? So let's say source string is what? This string here. Just follow, guys. So let's say this is a string that we want to concatenate, okay? If we count the characters there, 1, 2, 3, 4. Now, if we count the characters, is actually the 0, 1, 2, 3. Okay, but the length, okay, is 4. Now, if I at this position of source start counting, so I becomes 0, then at second position I becomes 1, at third position I becomes 2, and now at last position I becomes 3. Now that means if this loop finish running, the total value of I will be what? 3, right? So at this point now, if we say destination at position 3, that means we are saying at that position of 3, at position 3 of destination, we are assigning this guy. So I'm skeptical about that. Instead, I'm thinking that it should be the total length that after this stuff has appended, after the concatenation has finished, the total length should be uh, the destination should be total length that we get from the concatenation minus 1, so that we can target the last element and then say it should be this guy. Okay, but let me leave it at I first. So let's run this guy. Before we run, this is our function at the top. Okay, if I expand this guy, it's our function at the top, so we have to call it inside here. So to do that, I'm going to use the sample they did here. So I'm just going to copy all these things inside here. So it will just give me this output. So I'll copy it and I'll paste it inside the main function. So where did they use the string cat? If you look at it here, so S1 and S2. And look at S1 here. The value of S1 is hello and it has capability of containing 98 characters. And S2 is this guy, word. Okay, so we want to what? Concatenate, add word inside S2, and we have something like hello world. Okay, so let's run our code. Okay, error. This guy number 10, the one I was using to do sample, is not needed. So let me take it out. Okay, so let's see. Uh, okay, this one number 9, I only did int 0 instead of int I. Okay, so this is our string. Uh, so we add hello, and we have our output is actually not correct. Something is wrong somewhere. Hmm. Let's see. Okay, hello, word exclamation, hello world exclamation, word exclamation, hello world exclamation. So what do we have? We only have hello world. So let's see. Okay, So guy, what could be wrong? This is our algorithm actually. So
With that, it's minus 1 plus 1. Balance minus 1. No square plus 1.
I honestly can't hear you. Can you? I can't hear you. Hello? Like there is noise where you are.
Let me type it. Let me type it. Let me type it.
Okay, okay, please type, please type. Let's see. Oh, okay, okay. So guys, I think let him type. Let's see. Okay, I thought supposed to be length plus I. Yes, yes. So our algorithm is that scale leg somewhere. So this actually supposed to be the length plus I, and then we'll try to explain what it means. So okay, what this is saying is that length plus I. If length is 7 and I is what 0, so we are actually starting from 7. Okay, we are starting from the seventh element, of which it will actually be the last element. So we are starting from there to start the appending. Okay, this will not work. That is why this guy did not work. So on norms, we actually want to get the last element and then start appending from there. But if we output this, this is going to be okay. Can we do something? I like to practicalize. Oh. So if we do percent, if we say we should print from this guy, percent s destination, okay, from this point. So we are going to see what after this side executes, then we'll see what is the output from here, and we'll see why it didn't work. Okay. Let me. Okay, if you look at something, oh, let me
No, I'm not seeing it.
let me put a new line. Sorry, hello.
I'm not seeing it. Okay, I'm seeing your screen.
Okay, are you see my screen
What,
now?
what I wanted to say is that, that what I wanted to say was that very let me see your screen. That
Can you see
length
my
there.
screen now?
See that length now. No.
Yes.
Why is well let me just why I said length plus plus I. Should be I
Hmm.
is going to look over the second variable, second array, abi. So if I is looking over, how I
Hmm.
put it, the length of the first variable, the length of variable, if I is looking over, it's going to be adding to the length
Yeah.
of the
Hmm.
first variable. That's
Yeah.
why I was like, not length plus I.
Yes, I already got
Like,
it already. And I'm trying to
oh,
explain I'm trying to explain why it did not work. So that we can
oh,
see why it's not working. Now, I've given the output here. Let me run it. So this is the output. Guys, look at something. If you look at the original, this is the original text from here. Now, at the position of when let me say loop has started. So this is just like a way to actually do debugging and actually see what is wrong with your code. Okay, so if we stay from here, so we can see loop has started. Now look at it from where this guy started. Now at the last element of hello world, the last element of this hello is actually a space. So what I did here is that I removed the space and what I added w from this second word. That is why it's joined like this. W was there. Now it's what I became plus I plus plus I increased. Now what now happened again? At the second position, I removed the w, that is the last element minus 1. So that is what this thing is doing. So that's why it's wrong. So it removed the w and then what? Add the o at the second position of the source. Okay, so after I plus plus again, what did it do again? It removed the o at this position and then added what? The r, which is this guy here. So that is the thing that made this guy not to work. So what should have been the best thing to do is to say add I at every position. So if we do like this, it will start adding I. So if I is actually 0, it will what? Add, it will just remain the same, because if you add every of this source plus 0, it will be the same thing. It will be the same thing. So, and then it will what? It will add the source. Then it will move and then what? Add the next character like that. So if I run this guy, so you could see this guy remained the same. It added the source w. Now, what? The loop started again. Every of this guy remained the same because now destination has become this one. Then it added the o. Okay. Then what again? Destination has become this one, and then the loop continued. It added the r. Then what? Destination became this one, and then it added the l. Okay. Don't forget, this is the source, this is the what? The destination. So what again? Destination became this hello wall, and then it added a d. Okay, then like that until the final guy here. So at least this printf here, it actually helped to get the error and made easy understanding on how to debug. Okay, so the next thing I need to do here, so this one now, to actually finalize it and make it easy, is actually I will say at what? The length, the final length of the destination plus I. Okay, so making it to remain the same, that is just getting the final output, the final length, then I add the null byte. So this will give me the right output it should. So I can comment out the printf, and then our output should be the same. So we have hello and word exclamation, hello word exclamation. Then we have hello world exclamation, hello world exclamation, and then word exclamation. We have word exclamation, and then we have hello world. So why we don't have the last hello world? I think we are supposed to return destination. So if you read the concatenation, so you can see it said what? Returns a pointer to the resulting destination. So that is why we could not see this final word. I mean, this final hello word. So if you count 1, 2, 3, 4, that's what we have here. Uh, no. So 1, 2, 3, 4. So the last one is missing. So to get the last one, we'll return from here, return destination, and this should solve it all. So you could see now 1, 2, 3, 4, 5. So that's the solution. I think
Sorry,
we did,
please.
we got it.
Sorry.
Okay.
Hello.
Yeah.
That line 19. Please, can you explain why you use that no Like I use the first
The
of
null byte.
hmm,
Yes.
yeah.
Okay.
I don't
Okay.
know why. I thought if just normal I just if you just print you print text, you show it to hello world. If you print only text, you show it to
Okay.
hello world. Yeah, that was
Okay.
I thought.
Now, the essence of this null byte is because while we are doing this guy from this point, this source here has actually overwritten. I mean, when it say overwrite or something to overwrite something, it has actually what at this position it has written on top of, like it has exchanged the null byte, the terminating byte with the new string from the source. So it added all of that to what, to this destination. So if this thing is going to run correctly, if I disable this guy here, look at the output. I don't think if you get the output, see, the output is actually same, but this string is not having, if we don't add a null byte to it, it is not having a terminator, and there's something that we call buffer overflow or something in string. Like if you try to use this string like this without adding a null byte, it will cause some errors like that, like so. So this guy, now let me explain how it works here. From this point here, if we if we output this guy completely and this loop finish to run, let me print the length. Now I'm going to say print f, let me print the length of the destination. Okay, so after I do this one, I'll print the length again. So I'll say print f length. So present length is in decimal, so present d, and I will say string length, string length destination. Now, okay, uh okay, look at the length 13, right? Now let's print the length from here. Okay, the length is still giving 13, but according to the manual here, where is it? The point is that this the string cat, it overrides the null terminator of the original destination, it overrides the terminator of this one, and then what, append every character that is inside the source, and then what, at the end it add the null terminating byte. So obviously the point here is that this source string, or it has its own null terminating byte too. But we have already said that it should what, continue adding each of the character until it reaches what, this null terminating byte. Okay. Now the thing is, when this guy appends into this destination, this guy is not there, because we have already specified here that it should only keep adding until it has reached this guy. So once it reaches this guy, it will stop. So this guy is excluded inside every of the content of the source. So to make this strength function balance, we need to actually add this guy to the end of the destination. So this thing is now getting the length of the destination. Okay, so it is now adding what is adding, it's getting the length of the destination, and at position of I is adding the null byte. I don't know. I know that probably my explanation is not clear enough, but probably that's the best way I can actually explain now. But
Yeah.
you just need to understand that that's how it works. But just accept my explanation.
I have a
Okay.
question. That place you wrote why until why RSC and that is first
Okay.
array
Line 12.
because you not by
Yeah. Well,
because
line
because you
12.
know by hand. I'm
Line
not
12.
seeing your screen right now. I'm not seeing your screen. But the
Why
place
you
that you
not see?
wrote why, that line you wrote why.
Sorry. Why
That
can't you
line
see
why.
my screen? I'm coming.
I don't know if it's just legs now.
Can you see my screen now?
Network. No, it's on the show, but not sure. But let me get it. I've seen it. What how about your hand? I've seen it, yes. And line 12. Line 12. How about if
Okay.
you write? I thought, what if you write and instead of writing not equals to no byte, just write
Okay.
maybe less than or equals to no byte. Is it correct?
Okay.
We do
Why
the same thing.
it is less than or
As,
equal to?
if you write less than equals to as in equals to no byte, we still do the same thing.
Okay.
That's what I'm asking. Yeah.
Mm, if we do it this way, what does this mean? What is I at position that is source at position 0? Of course, it is less than this guy because this one is always the last guy. So it should work. Okay. And if it is equal to it too, it should work. Okay. But the truth of the matter is that whenever the compiler sees this null byte, it will terminate. That is the meaning. So I don't think it will actually work properly because once it sees this guy, it is going to terminate. And I don't know. I'm just that is like the way I understand it. But let's run it if it gives us the same output. Can you see now? It has reduced it to 6. And let's see what is happening. Let me bring out the printf in each of the looping. So let me take this one out. This one. So what is happening here? Even the printf is not what? Is not printing. So like nothing is working. Nothing is actually working. Why? Because this guy, it means to terminate. So once the loop sees it, it's going to terminate. So the best of my knowledge is not. The only thing we can say is even if we do this one, it might not work, sir. It still didn't work. Okay, now okay. Sorry, I think I get the meaning now. The meaning of this guy, this null byte, is the same thing as 0. Thank you, Lord. I remembered. So see, if you say 0 or um the null byte, is the same thing. Let me confirm it for you. So if you say man ASCII and then you check the ASCII table. So if you come down, look at the null byte, null character. Can you see it? Can you see the decimal value? 0. So what are we saying here? We are saying why 0 is less than or equal to 0. So nothing will be done. It is 0. So I can actually put 0 here. Or if I say why this guy is not equal to 0, that means this thing is the what? Of course, 0, why 0 is not equal to 0. So it will give me the output. Okay. So why this is true? Why position at this is not equal to. So what you need to understand is that this is either you can use 0 or you use the null byte because they are the same thing. So this is the ASCII, is the ASCII character, the null byte, and the decimal value is 0. The hexadecimal value is 00. The octal value is 000. I think that solves it all. Do you understand now? Hello? Who has the question? Yes. Yes, Brendan. Yes, they are the same thing. Okay, so imagine just to explain this, we use 1 hour. Uh, so guys, so let me correct our algorithm. Our algorithm before, so I won't make mistake of that. So this has to be the string one has to be the length plus I at position of I, so that it will remain the same, and from there to start what doing the looping or the loop. Another question, clarification, addition, subtraction, multiplication, division. Can we take a look at another one? But I'll wait for our response first. Guys, do we get the logic? Caroline, I think I only have Carolina. Okay, Caroline, Brandon, and then Ikene. Okay. That means everybody understood what is happening. Okay. Let's try another one. And probably we'll call it a day from there. Now let's see this one. Or probably you guys will choose which one we should tackle. Should we tackle this one? This one concatenates to just two strings too, but the concatenation is based on the number of bytes given. For example, if you copy this guy now, this is how this function works. I will take this guy and I will use it here too. So I'm going to replace it with this one. So the syntax will change string n cat, and it will change here too when we are using it string n cat. Oh no, I'll copy that. Let me copy their sample here so we can just use it as the output. So if you look at this one, okay. Now you could see that this one have the destination, the source, and then n. Now let's read the description. It said write a function that concatenates two string. Prototype. Now this string ncat function is similar to this string cat function, except that it will use at most n bytes from the source, and source does not need to be not terminated if it contains n or more bytes. Now all this English, what does it mean? This man is going to concatenate source into destination based on the given amount of bytes to concatenate. That is, this n here is like, if I'm saying that I want to join source to destination, it is telling me that I want to join only, I can specify that I want to join only 3 characters. I want to join only 10 characters from source. I want to join only 12 characters from source. Do we understand this? That's the meaning of what this string card, that the way it works. So it is going to join the amount or the given amount of characters it should what it should join from the source into the destination. So this is saying that the algorithm will change. That is, for this function to concatenate two string, it is actually dependent on the number of given bytes, and it is dependent on the fact that source is not equal to the terminating or the not terminator. So what does this mean? Our condition for the while loop will be that as long as the position of source I is less than the number of bytes given, and at the same time the position of source is not equal to the null byte. I don't know if this if everyone is getting this understanding. So yeah, it is saying that the position of the source string is lesser than the number of bytes, because of course the joining to happen, it is dependent on the given amount of the what to add. So if it is 3 here, that means the position of source, okay, is not equal to 3, so that while it is not equal to 3, it will keep adding. Let's say source is gets, okay, so let's say source is gets, so let's say I is equal to 0. So at the position of source, when I is 0, okay, 0 is not equal to, let's say they put 3 here. So just try to just watch these 2 points. So let's say they put 3 here. At the position where source is what? When I is 0, I 0 is less than 3, so it's correct, it will add it. When I is equal to 1, 1 is less than 3, it will add it. When I is equal to 2, 2 is less than 3, it will add the character T, okay? And when I is what? 3, 3 is less than 3, that is what? False. It will not add s, it will only add get, and then it will what? Terminate the loop. So that is what this condition means here. So at the position of I, making sure that what? As long as it is less than the number of given bytes, and as long as it is not equal to the null byte. So what do you need to do? The position at the destination, okay, append the position at the source. So this is the only thing that added, the only thing that changed it is from the condition, because the adding or the joining of the characters is dependent on n. So when we now run this code, every other thing remain the same, okay? So every other thing from here, they remain the same. So it will keep adding the source based on these two conditions. And then after the end, it will what? Set back the null byte to this guy. And that's it. So if I run this code, oh, let me this one, let me put it back to n, and then okay, that's all. Okay, line 7. Okay, I'm not supposed to terminate. So can you see? Now let's see. Look at this guy on line 35. They set it that S2 should add to S1 only one character. Okay, why this one is what? Okay, so the same thing is printed, and then they come back to line 39 and they say that S2 should add to S1 as much as 1024 characters if it is possible. So adding this S2 is much, very long. It is going to add all of the characters. But let's inspect this with our loop. Our printf. Let's see. Can you see? Loop has started. Now, LO W. Okay, source. It added the W to it. Now, the other part, loop has started. That is, this is for this one. Which one printed? Okay, line 36 printed. This is line 36 from here. Okay, then this one, line 37. Okay, it kept adding because we are printing and we are printing, so it was repeating itself. So it added word to this one, and then line 39 repeated, and what it said, it should add as much as 1024 bytes, but it cannot add all of that, because if you look at it, okay, it will add because it will add all the string of s2 to s1. So it is actually this one here, if I'm right. Yes. So Okay, 40, 41, 42. So, yeah. So, guys, the point is this string n will add according to the number of given bytes. Mm. Um, did we get it? Is it clear? Any question on it? Can we see one more? Hello, guys. Does anybody have any specific question? Probably I should just use that as in the next 20 to 30 minutes. Okay, I'm seeing question. I'm so confused. I'm lost, guys. Like for the whole thing, I'm lost. But I will research and get back to the video later after the meeting. Wow. Okay. Anyone with specific question or a particular task, specific task you want us to look at. This is how to copy string from source to destination. So we have two type. The okay, this one is a string n. So this one copies the given amount. Okay, and then we have this string to compare to string. We have this one that reverses the contents of an array. I'm not getting response from us. That means we understood everything. Probably we should call it a day, guys. I only have three. We only have three of us,
Yes,
and
we understood. Understood. Can we can we do the array?
array.
Yeah, this one. This is reversing array.
Okay, this one. Okay,
Yes. Yes.
okay. Now let me take it and let's see how we can do the algorithm. This will be our last this because they've taken the power. Um. Okay. Okay, guys. So what does this function do? It's going to reverse the contents of an array of integers. Now, let's try to break this down. One thing I will always say is, although like this part of the best way to approach a problem, especially all the simple ones a bit, is actually you start from the output. You actually try to make sure you understand the output, like how it will look like. Then before you now build your solution on that. So that means if suppose we have an array like So let's say we have an array like array of 5 elements, and it's like 1, 2, 3, 4, 5. Okay. So what is this going to do? That means reverse would be 5, 4, 3, 2, 1. So that means the reverse will be in this way. Now, how can this be? How can this how can we approach this? First, we understand that each element of the array is indexed by a zero, right? So first element is what? Zero. And then last element will be what? So guys, let me ask question. Last element from this, what is the value of the last element? The index of the last element. Okay. What's the index of the last element?
4.
4, right? So 0, 1,
Yes.
2, 3, 4. So the index of the last element is 4. So now with that, how can what is the length of the array? The length of the array is actually 5 from what we can see, or we call it size of the array. Okay, so the size of the array is 5. But if you want to, there's something they used to the computer will calculate when it's if you run size of operator and you write reference array, it is going to calculate the size by doing the number of by basing it on the bytes. I mean the data type of the array. For example, the length of this array is 5, and then the individual elements of this array, they are what? They are integer. So it's going to do 5 times what? The integers. So in that case, it will return the size as 20 bytes. And this is saying that it's the total size of this array in memory. So this is different from when we say the length of the array according to the individual element, the total element forming it. So this one is size of, okay, this is size of array in memory. Now, one thing we've been able to establish here is that we've been able to we understand that the index of the last element is 4, the first element is 0, and the length of the array is 5. Now, that means, let me break this down. This means if I want to target the last element and set it as my counter or starting point, okay, I will do length of array minus 1. So suppose length is 5 and last element is 4. So of course, last element, I mean targeting last element will be length minus 1, right? Which is 5 minus 1. So I'm going to start the reversing from the last element. But this point now is that if we look at this logically, we actually need to we actually need to do like a kind of swap for this guy, because how can we say we want to take this guy from this position and put it to this position, and take this guy from this position and put it to this position, take this one from this position, put it in this position, take the number two from this position and put it as the what second to the last, take this one from this position and what, and then yes, it will be there in the position, and then take it and put it back. So that's in this case. So we will be needing something like a temporal space where we can put exchange the values and do the swapping, and then what, put the values back to where they are. I want us to understand the algorithm. It is like a swapping method because we want to reverse. How can you reverse? And even we are printing, like we are printing them in reverse order, it would have been easy because we will start our printing or the outputting of the values from the last element. So we can get the last element and then start to do um last element, print this guy, then move backward and print this guy, and print this guy, and print this guy, and print this guy. But the best thing that we can do is we want to reverse it such that in the same array, we want to what? Exchange the values for each other. So the logic is to reverse the array elements, the logic is to use a swap mechanism. So such that we would need two counter for the first and last element, and the last and first and last position, sorry. So guys, let's bring this into practical life. Think about it like uh you want to exchange the position of something. Okay, visualize it in your head now. Think as if you want to exchange the position of something. So you take the first one and you take the last one, and you move it and put it in a space, and you exchange. Okay, you take the first one, and you take the last one, and then you put them, exchange them together. But it would have been easy like human taking something and exchange it with hand. But if it is in the case, we need to do like a swap method as a form of logic, as long as we are trying to instruct the computer to do something. So two counter, one for the two counter for the first and last position, then a temporary variable to hold the positions for swapping. Okay, so we can say first counter equals I. And we can say second counter is J. Now what do we do? How do we go about this? We will say, so we are trying to now loop, okay, we are trying to loop uh two times. Then we will need what? We will need the length of the array. Okay, okay. So we'll need the length of the array, and so they're giving us already from what we have here. They give us the array and they give us the size of the number of elements in the array. So what can we do? Let me take this down. Sorry. Okay. So number 4, then we loop over the two counters. Okay, we loop over with the two counters while we swap the positions. So if we have something like loop, we say I equals 0, and then we say j equals, now if I is the first element, and then definitely j, if j, can j be the first element too? Okay, so let's see, we are going to be using a for loop though. So why I is 0 and j is 0. So let's say for I equals 0 and I is less than n, that is the size of the array, I plus plus. And then we have another for loop, in nested loop for j is equal to, okay. Now I think j cannot be 0 because we need j to be the last element and start picking j from that point. So j will need to be n minus 1. Okay, so this will what, last element, and this will be, first element. Okay, so that would be j is equals to n minus 1, and j is, and at that point j will have to be greater than or equal to n, and then we'll say j plus plus. I don't know if we are getting what we are trying to say, because we are trying to come from the front and then from the back. So if we say, let me go to example. If we say this is I 0, and then we say uh, this is j, this is j, and the size of this array is 5, but the last element is 4. So j is n minus 1. It give us this guy. Okay, 4, the fourth element. So when j is this, then we will try to make sure that j is greater than, okay, it won't be that j is greater than, we won't say why j is greater than n, no. It will be that why j is greater than or equal to 0, because we are trying to go backward. Okay, so this is, we are trying to get to this point and we are trying to what, move from this point backward. So we'll say, okay, j, and j is what, then what are we going to do? We'll say our temp value should be, let me use capital, our temp value should be equals to, so we store the first element into inside temp. So we say our first value should be array at position I. Okay, and then we'll say, then the same position of array at position I. Now the first element of I, of array now, we'll now set it to be equal to the last element, which is array at position j, right? So we are picking the last man and put it inside the position of the first man. We are overwriting the first one there, right? Then what do we do now? We now say array as position j, the last element now at this position of I, which is I is 0. Okay, and at the position where I is the last element, I mean at the position where j is the last element, so we say array as position of the last element, put in, I'm going to explain this again, the first element. Okay, so instead of putting the first element, we are going to put in temp, because temp will be receiving all the first elements, and then array at position j will be entering its value inside every position of what, the first element from the left, coming forward, coming to the right. So this one will be going from the right, going to, this one will be coming from the left going to the right, and this will be coming from the left going to the right. So this will be going, this will this will put into temp the first element forward. Okay, so put into array the last element backwards, putting into array from the last element backwards, and then put into array, okay, put the first element into the last positions of array. All that this is doing is that, take a look for this, take a look at this first element of the array. Let's say, let me write the array down here so you can visualize. I said it's like a swap method. Okay, so if you take for instance this guy, so if you take this guy now and put it inside temp, okay, right? And what is going to do, the last element now, this one 5, it will put it inside what, the first element. So it will take 5 and put it inside I, 1, right? So it has shifted 5 to that point. So what it's going to do now, the temp that it has taken before, it's now putting inside what, the last element. So this position here, this one that has stored here, that is the one that has what, it has taken from this point, the first element, put it inside here. So it will continue like that as the loop what goes, the I plus plus and the j plus plus. So we can actually implement this algorithm now, and let's see what will be our output. So I'm going to open a new, and I'm going to copy, I'm going to let me copy the sample that they have here. So how are we going to do our algorithm? Let's put it here. So what do we need? We need to create the variables. So create variables int I, j, temp. Okay, so we'll use a for loop for I equals 0. I a at position of I, okay, is less than what, the size, the given size, and then what would say uh I plus plus, and we'll do another for loop. That is j is equal to n minus 1. J is greater than 0. J plus plus, and then we'll say now from here we'll say temp is equal to a at position of I, and we'll say a at position of I is equal to, okay, now we can't do j plus plus here because we are moving backward, so we have to do j minus minus. Okay, we are moving backward because we are going back to 0. So in the first place here, j is actually what? If the size is 5, okay, just like the size of this array, then j will be what? The fourth element, 4. So 4, 3, 2, 1, 0. So it has to be j is what? Greater than or equal to 0. So then this one will now be equal to a at position of j, that is last element. And then what are we going to do? We say that a at position of I should be what? Should be temp, right? So after everything, we are to return a, the array. I'm pretty sure they put it there, that we are to return. Okay, of course we have okay, we are not to return anything. Is void. Okay, so it will just do the reverse, and then it will give the value. Um, I should be sure that our this output should be correct. So okay, what I copied the other time is not even correct. This is for a function that will print. It's going to be printing space and comma. Okay, so not this.
Naro, naro.
So that will be here, and then we have the main function. Okay, so can we see what will be our output? What do we have? Reverse array. So there is something wrong somewhere, somewhere, somewhere. Okay, so right. So can you see where the error is? Who can guess where the error is?
Hello,
How many of us are there? Wow, just you and I.
Michael. Can you hear me?
I can hear you.
Okay. I think here when you said AI, a array of I, should we not put n there?
This place.
The last one.
Okay, this place, right?
No, the last one after the follow.
After the for loop. Okay,
The, the last one, yeah.
this one.
Yeah. Should you not put a array instead of
Like
array I,
like this.
we should put
You mean like
No,
this?
no.
Okay.
Yeah, A inside a array I, we should put a array n.
No. Let me show you where the error is. The error is
Okay.
from this J. We said J should be equal to the last element, right?
Yes.
Okay. So we are now seeing why J is greater than or equal. Targeting the last element. So it will be at
Okay.
array at position of J. So, and I'm sure that that is what. Okay. So that okay, it is not even reference. So it should be in the algorithm. That's where the error comes from.
Okay.
So we are targeting the last element. So A at the position of the last element of which is we said J should be equal to n minus one, and
Okay.
that is the size of the element minus one to target the last element. So if this size is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this size of this array is 13 actually. So 13 minus 1 will give us this last element. So once it gives this last element, it's now going to do what? It's going to do j minus minus. That is, it's going to be moving from this to this to this to this to this till you get to 0. So that is why we say that at the position of the last element for the array A, as long as it is greater than 0 or equal to 0. So you know this is greater than 0 because 12 is greater than 0. The last element is element 12. Element 11 is greater than 0. Element 10 is greater than 0. Element 9 is greater than 0. Element 8 is greater than 0. Like that. And until you get to 0 is equal to 0. So from there, it will do the swapping here. That is the reverse. So we should get our answer correctly now. Uh we are not still getting it though. Let me see. So okay. Why are we having the same value? Let me try to do print f. Oh. So I'm supposed to. Sorry about that. Okay. So now what did he do? This one is correct. He took the first element and put it inside them, and it set the value, the last element inside as the first element. So it printed everything like this, and this is now correct. Okay. So I'm coming. Okay. So a position of I is equal temp, set into temp rather. Set the last element as the first element, and then set the temp as the first element. Uh, what could be the error, guys? Guys, can we think?
Uh, the last part, are we not supposed to do with the last element, which is J? IJ goes to temp, the last one.
Like, what should I? The last number 16. It should be. It should be what?
Yeah, IJ goes to temp.
I didn't guess. Can you type it so that I can see what you are talking about? I didn't get it. Okay. AJ. Oh, okay. Set the last element to be uh set first element into temp, set last element into I as first element, and then set temp. Oh yes, you are correct, because what is happening here is like I'm setting the first element because this is the same thing here. Okay,
Yeah,
yes. Yeah. It should work now. Ooh, I didn't get that. Segmentation fault. Mm-mm. Something is wrong somewhere.
yeah, I think something's wrong somewhere.
Something is wrong somewhere. I'm trying to observe the code.
What could be the error?
Okay, so probably is this one. It should not be, it should be greater than zero. Mm. Uh, okay. Did you get the error? The error is coming from the fact that it has to be that the two are happening at the same time. So it should be that y position at position at I is less than position at J. Uh, uh, such that this guy, hmm, how do I explain this? Let me see. Hmm, Okay. Okay. So you are taking it yi is less than j and yj. I think we actually need just a single for loop, not
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 two.
a yeah.
Not two. So a single one.
It's a single
You
for
mean
loop, right?
not the two for loops?
So oh, wow.
Yeah, yeah, yeah. I think that's the error.
Yeah. So we are trying to put I to first character and uh yi is less than, now j will be equal to yi is less than uh I can
J
set j
minus one.
from here. Yeah, j is n minus 1, the last element. Okay. So I is 0 and I is less than j. Okay, so I is the first element is less than the last element, I plus plus. So we'll say, okay, set the first element into temp, set the last element into I, and set the first element from the temp into j. But we have to increment j, so we can say j plus plus from here.
So,
Okay, or we can still put it together here. This is allowed to in for loop, right? But we are going backward, so j minus minus. So it's actually work. So we need to configure our algorithm. Our algorithm is wrong
yeah.
in the sense that we need just a single for loop. Okay. So why we say a I is 0 and I is less than the last element j. So while you are incrementing I going forward, then j should be going backward. That is j minus minus. And what we now say is set the first element inside temp and then set the last element inside the first element and then set temp inside the last element. So that's how it has actually worked here. So thanks, Brendan, for the contribution. It actually goes a long way.
Thank
Wow.
you.
I think we can call it a day from here.
Yeah, we
I'm
can.
exhausted, and
Yeah,
at least had it been had it been everybody can have a physical way to meet. When you are discussing these algorithms, I mean problems like this, you get the answers easily. Other than you are alone, or even the rubber duck sef sometimes can be boring. But
yes.
we keep building ourselves. Yeah. All right now. Thank you so much. So have a wonderful day and take care. Bye.